Wonderful, thank you. All right. And today the title of my presentation is presenting teaching insight on the basic, the computer, the graphics, and through the matrix, the operations. And I'm W.Y. Chen, and from the Texas A&M, the University, Texarkana. And welcome to join my sessions. My presentation including the following, the portion. The first one is introduction of the computer, the graphics, and then the transformation of the functions, and then how do we use the matrix and do the transformation of the vector or maybe some coordinate, the object. And finally is I have some conclusion about my project right there. So what is the computer, the graphics? And this is the definition I get from the book of the computer, the graphics, principle and practice. And the computer graphic is the science and the art of communicating visually. And the visual respect, this one is the aspect of communication, usually is about the human being to the computer. So it could be from computer to human or from human to the computer. And how about the applications of the computer, the graphics? Perhaps you guys, see this the filmmaking a lot of the time is using the computer, the graphics, and then to generate a lot of the picture and then put into the film. So this is the one of the major applications. How about the other one is, hey, we get the CT scan. So we can scan the patient. So based on the picture, then we are able to know what's happening about inside our body. And the next one is, hey, the one is my student, they like that is the video games. And then the next one is on the architecture. So there are some major applications on the computer, the graphics. And how about the transformation of the functions? Okay, so in this course of the computer the graphics, in the year of the 2024, I teach my mathematical modeling the course, and I have 10 students, and 8 of them, they are the computer science major, and then and 2 of them, they are the math the majors. And the computer science major, they are really interested about learning of this kind of the transformation of a graphic and then using the matrix, the operations. But you will find that there's some kind of the similarity of the matrix, the transformation, and also the function. If we say you had the y go to the f of x, how do we move the function up and down, left and right? So they have a similar kind of the nature over there. So this is usually the transformation of the function, up and down of the functions, left and right. You can stretch your function is the vertical dilation, or you also have your horizontal dilation. We can also flip the graph. We have the minus the f of x, or we can reflect the graph to the y-axis if you have the f of the minus x. So this will be usually we present to our college algebra to the student. But how about we have some vector right there? How can we use the matrices and then to transform your object into the one, we want to see? So mainly is based on the addition or the multiplication of the matrices. On the other hand, I'm also using the parametric, the function, and then to help me on the graph. And I also need to generate the vectors. All right. And then the first one I would like to present is, hey, how about the translation of a vector? So suppose that you get your vector is the W, the components is U and the V, and then you're going to translate this vector into any coordinate given by the P and the Q. So we get a new point will be the U plus the P, and then the Y coordinate will be the V plus the Q. So this will be the new coordinate. So we can look at the example right there. The W is my original, the vector or the segment of the line. And then the new one, the transformed one will be the T1 times the W, which is defined by the one I presented in before is the first vector plus your second, the vector. But how about if you have the multiplication of the matrices with your vector, or I say is the coordinate the matrices. The coordinate matrix is you put all the vector together. You form your coordinate matrix. The M is your transform the matrix. I have the coordinate right there will be your A, B, C, and D. So you have four numbers right there. These four magic the number, I'm just using a 2x2D matrices and then to illustrate about the changing of the function. So we can have different kind of the transformation. So I will say will be around 4 to 5 types. So we can summarize that by using the multiplication of the matrix. The first one is called the scaling. The scaling is we look at the diagonal is the element is A and D. A and D, we assume that they're positive numbers. And this kind of the scaling will be uniform if we set the A and D they're positive. However, the other one is called the non-uniform the scaling. So let's look at the example about the scaling one. I mean, this is the uniform one. I choose the A equal to 0.5, the D equal to the 0.5. You see that you get the input, the scene, and then the output, the scene will be much different. The transformed the scene will be much smaller because you compress on the X coordinate. You also compress on the Y coordinate. So this is what I say is called the uniform, the scaling. However, you also have the non-uniform one is I put the value of the D equal to 1, but the A equal to the 0.5. So that I'm going to compress on the X, the component, but I don't have any changes on the Y component. So this one will be the other, the figures would like to illustrate to you like that. So besides this uniform and non-uniform, the scaling, I also have the other one is called the shearing. So shearing will be a little bit kind of tricky. So you can shift your graph, hey, to the horizontally, either to the right or on the left. And then you can see your graph is vertically up or down. This one is controlled by the number, the B, and also the coordinate, the C right there. But of course, I will put the counter, the coordinate right there. If I want to have a horizontal, the shearing, then this coordinate, I put this one equal to 0. If I want to have a vertical, then I will choose the first, the row and second column, the number is equal to 0. However, the C and the B, I don't have any kind of the limitation except that B and the C, they are non-zero, the numbers. If your B is positive, so you can look at my graph below. This is my horizontal, the shearing. So I choose the C equal to the 0.2, but the other value equal to 0. So you see that the graph shift to the right-hand side. And then the next one I have is I choose particularly the other number equal to the minus the 0.2. Then I will shift my graph vertically, going down by this factor of the number. So how do you choose up and down, left or right? Then these two coordinates has the purpose right there. The other one is we usually present to our student is, hey, how about you rotate your object counterclockwise by using these matrices? You get the cosine and then the sine function. So you rotate this one by the given the angle of the theta. So this is one of the example I gave in my class is, hey, how about your angle equal to 20 degrees? So what will happen of your object? You rotate by the 20 degree counterclockwise. So this is the other type. And then about the rotation, we also say more precisely is, hey, how about we are going to reflect this one on your y-axis? You can rotate that. So the magic is we are changing the number in here instead of, before that I'm using the positive one. Now I'm using the -1, then my x, the coordinate, I will flip this one to the negative x, the coordinate. So I will flip my diagram to the other side. If I switch this coordinate right there into the -1, then I will have the reflection on the x-axis. So this will be the issue. But you can think of yes, hey, we want to have the flipping your graph on the x-axis and then to your y-axis, then my transform the matrix will become the -1 and then the -1. So I let my student and then to try it. Hey, they know the reflection on the x-axis and also on the y-axis. So what will happen if you generate the new matrix? So let them to explore this idea right there. And then the next group I'm using is, hey, we say this kind of the reflection or the rotation. How about we put all this one together? This one is what I say is combining your transformations. So you have different of the matrices. So the first one, I have the M1 will be your uniform. I'm sorry, this is the M3, I should say. This one is the uniform, the scaling. And then the M2 will be your vertical, the shearing. And then this one, I should put the M1. So this will be my reflection with respect to your y-axis. So you combine them together. So they have a sequence. And students, they can follow this kind of the sequence. Then they will generate the picture. Hey, finally, I get the one that I want to see. So this one is what I presented to my students. So this one is the final, the result. So you get the uniform, the scaling, and then you have the zeroing and so on. So they like that. They like a lot. And in my classes, I ask them to use later on, I will show the website, the link. So the link is mainly using the Cornell University, the computer science. Then they have the link and then to generate this picture. After you get your matrix, you transform the matrix. So the other one is, hey, how about on the 3-dimension? You can also enlarge your object, let's say on the factor of x-axis by 2, or you can rotate your object on 3D and then by the 45-degree counterclockwise. So this kind of the picture, I'm using the decimals and then .com to generate that. And I also share the link with my students so that they are able to play around the game and then in the class, they have a laptop computer and then to follow my demo. So this is the website I'm using and then to generate the picture. So this is the website from Cornell University. How do they reflect the graph and then left to the right or up and down and so on. So my students, they like that. And I also give some kind of the class, the problem to my student. So for example, in here is, hey, we get to transform the matrix is the M equal to the 0, 1, and then 1, 0. I have several the vector in here. So what happened of this kind of the graph later on? So I let them to explore that. I have the worksheets and then so they are going to explore. So this graph is, hey, they're going to reflect your graph along to the line of the y equal to x. Before that, they may not know what's happening. But after you enter the information into the decimal, then they're going to find out this on their own. Put this one in a more challenging the case is, how about reflection of your y equal to mx? So we always say the y equal to mx plus the b in my class of the college algebra. But how about we remove the b, we just put the mx only. So the m is not equal to 0. So this one is the general, the formula. And then how do you reflect your object along to the line y equal to the mx? This one is pretty cool, all right? So I use the example in my classes. Let's say how about the small m equal to 2. Then I'm also using the website from the Cornell University. So I'm going to rotate my object along to the y equal to the 2x. So this one is my new and then the scene. And then, so they enjoy that. But the next case is a kind of challenging. Nobody in my class is they're able to see what's going on until they go to the website and then they explore this one. This matrix is your M is X, I mean the first row is 1 and minus 0.5, and then the row will be 2 and minus 1. If you guys work on the determinants, the determinants of this matrix of the M will be equal to 0. So if you get the determinant equal to 0, then what happened of your object? The object will be, say, the degenerate case. That will be collapsed. So you only have a line is coming out only. You don't see anything. Your object becomes totally collapsed into one line only. So this is one of the cool stuff that we have. And the other one is for the three-dimensional, the cases. If you rotate along to the three-dimensional, this one is rotate along to the z-axis. So I let them to try it on it. So finally, I have my conclusion of my presentation. So what I covered in this presentation is we cover the transformation of the image, and using the matrix, the operation, we have addition and the multiplication of the transformed and object. So we have the translation, scaling, and shearing. And I also cover the applications of this computer graphics in different area, engineering, medical, the image, and then also on the movie the making. So thank you so much.